All right, guys, welcome to lesson 6.8. This is going to be our last lesson. Today we're going to be finding the derivative of composite integral functions. So first of all, let's talk about what a composite integral function is. Now you guys know what an integral function is. An integral function is where you have a function that has an x as a limit. Right? But we're talking about composite integral functions. Well, in case you guys don't remember, a composite function is a function where you plug a function into a function. And so in that case, what we're going to have then is you're going to have actual functions as your limits. And it doesn't have to be just in one spot, but you could have an entirely different function here. So this is what I'm going to call a composite integral function. And today we're going to learn how to find the derivative of these things. Okay, and so that's kind of our goal there. So let's go ahead and move on a little bit. So we're going to start off by doing it the long way, but after that I'm going to show you a short way. The reason I want to start with the long way is it kind of lays a nice foundation. It connects to the things that you already know, but there are some problems where you literally can't go this way, and also it takes too long. So I have a shorter way for you, and that's the way that we're going to use usually. But for now, let's start with the longer way just to kind of lay that foundation. So I want to find the derivative of this problem here. So I want to find f prime of x. All right, so step one, I want to integrate and use the fundamental theorem of calculus to rewrite it. So I want to rewrite this problem using the fundamental theorem of calculus, and that requires integration. So I'm going to integrate this. If I integrate 2t, what do I get? If I integrate 2t, I would get t squared, right? And you put your limits out here. Next, we're going to continue doing the fundamental theorem of calculus, and that's where you write the t squared twice, once where you plug in the upper limit, and once where you plug in the lower limit. Okay? Now, you could simplify these if you wanted to by doing 3x squared plus 1 squared, and then you could do 2x squared. But I'm gonna go about it a little bit of a different way. I'm just going to use the chain rule on these. So we have an outside function, right? The outside function there is written twice, and then we have two different inside functions. Use different colors for them because they are different. So I'm just going to do the chain rule on these. So now I'm ready for step two. Step two is to find the derivative. So that's going to be f prime of x is equal to what? Well, let's do the derivative of the outside first. The derivative of the outside, I'm going to throw the power to the front, and I'm going to take 1 off of the power using the power rule. And we leave the inside alone. And then we're going to multiply that by the derivative of the inside. The derivative of the inside there is 3 minus, and then I'm going to do the derivative of the outside again, same thing. And then I'm going to multiply that by the derivative of the inside, which is just 2. All right? And if you wanted to, you could simplify this, but I really don't care about going much further than that, especially for our lesson today, so I'm going to stop there. But there it is. Okay? So the longer way is to integrate using the fundamental theorem of calculus to rewrite it, and then go ahead and plug it in and just find the derivative afterwards. So rewrite it and then find the derivative. That's the 2 steps. All right, so that's the idea there. I want you guys to go ahead and try one like that. So let's go ahead and have you guys do your first homework problem on your homework for tonight. This guy here. So go ahead and pause the video here and see if you guys can go ahead and try out that problem. When you unpause it, I will show you guys the solution. Okay, so there you go. Could have written your answer in a few different ways, I suppose, but that's my final answer. So the integral of sine t is cosine. You're going to plug the x squared in and the ln of x, and I have successfully rewritten my integral function, so it's just a normal looking function now by just doing the integration and the fundamental theorem of calculus. And now I want to find the derivative of that just using the chain rule. The derivative of cosine is negative sine, so I get a sine here, and also you'll notice we have a negative in the very front. And the derivative of the inside is 2x. Once again, over here, the derivative of cosine is negative sine, which causes this negative here to become a positive. And so we have sine with a positive now. And then the derivative of the inside, the derivative of ln of x is 1 over x. And so that's how I've written my answer there. Okay, just left it at that point, didn't need to go too much farther. Now, I picked problems that were quote-unquote easy. And what I mean by easy is that the integral is simple. You just integral of sine is cosine, right? Or on the one that I did, the integral of 2x is, x squared. Easy stuff to integrate. But sometimes it could be a really big pain in the bum to have to integrate some of these things. So the shorter way I'm going to share with you in a moment is very helpful. Now here's what I want you guys to notice something. I integrated the sine, and it became cosine. But then we took the derivative of it, and we went back to sine. So we started at sine, and we ended it at sine. Why? Well, we ended at sine because we integrated it and then took the derivative. Those two things are opposites, so they undo each other. So I want you guys to notice something. Whatever you have here, that's just going to end up down here. Second thing I want you to notice is that it used to have a t here, but in this case now it's got an x squared, and this should have had an ln here actually, and an ln of x here. Why? Because when you do this process of the first fundamental theorem of calculus, you plug them in. So you're plugging those things in. I also want you to notice that we're also multiplying by the derivative of those things there. So that brings us to our shortcut, which is really just a formula of how to find a derivative of a composite function. And here's what we found. We found that, okay, fine, we're going to integrate this and it's going to become something else, but then we're going to take the derivative of it, which sends it right back to being normal. So you're going to have this same function written twice. Okay? Because you integrate it and then take the derivative of it, which just takes you right back to where you were. Second, we plugged these in to that function, right? So now there's an h of x here, the one on the top comes first, and there's a g of x here. Third, these each got multiplied by the derivatives of the inside. And that's a shortcut for finding your derivative of r. Okay? So there is the shortcut. All right. So we're going to be using the shortcut and the formula method now to do the rest of these. Now, if you ever want to do the longer way, you're welcome to. But the downside is you may not be able to in some cases. Like in this case, we've never learned how to find the integral of ln. So if you tried to do this the long way by finding the integral of ln first, you would get stuck. And so there are problems where they'll make it like that. So you kind of want to know this shortcut method, right? So here's what we know. We know that we're going to integrate ln, but then we're going to take the derivative immediately after that. So if you integrate ln and then take the derivative, it's kind of like they undo each other and you just get ln. And because of the fundamental theorem of calculus, you get it twice where it's being subtracted. And for the first one, you're going to plug in the upper limit. And for the second one, you're going to plug in the bottom limit. And because we are doing the derivatives of these things, you have to multiply it by the derivatives of the insides also. Okay? So it's a three-step process. First of all, you write this number here and here with a subtraction sign between them. Next, you plug in the limits, and then third, You multiply by the derivative of the insides, and you're done. So that's it. Much faster, wasn't it? Much faster. Let's go ahead and try another one here. So let's do a guided practice. So we have a composite integral function here once again, and they're asking us to find its derivative. So what is the shortcut for that? So I'm going to write something twice with a minus sign. What is that something? Think about that for a minute. What am I going to write twice with a minus in between? I'm going to write the sign, but I'm going to put blanks here because it's not going to have x inside there anymore. It's going to have something else. But I'm going to write that. So now that moves us on to the next step. What am I going to put on the insides there? What do go inside of the sign functions? Well, the top number goes in here, and the bottom number goes in the second one. And then I have a third thing I need to do. I need to multiply each of these in the front by something. What am I going to multiply each of those signs by? Think about that for a moment. See if you can figure out what I'll multiply each one by. They're different things. And then check to see if you got the same thing as me. All right, so what you're going to multiply this by is the derivative of the inside. So the derivative of e to the x is just e to the x. So I'm going to put e to the x there. And this one I'm going to multiply by the derivative of this inside, which is 6x. And that's the fast way to find the derivative of a composite integral function. So now I'm going to give you guys a homework problem to do, which means we're not going to go through it step by step. I'm going to let you guys do the whole thing from beginning to end on your own. Go ahead and find homework problem number 2 and do the shortcut or use the formula method to find the derivative of this composite integral function. And when you unpause the video, you will see the solution. All right, there you go. So we're going to write this function twice. Got my little 3 right there. You're going to write that function twice, but with nothing on the inside. We're going to be replacing the inside with the limits. So the x cubed goes in here, and the 2x goes in the second one. And then we multiply by the derivatives of those numbers. So the derivative of x cubed is 3x squared, and the derivative of 2x is 2. And that's our derivative. Okay? So let's not forget, though, even though we're using a shortcut and a formula, formulas are really hard to remember. But it's not hard to remember if you understand where they come from. It helps you a little bit be able to figure them out. So just to remember, how does this formula happen? Well, we're integrating a function, but then we're going to take the derivative of it. And those two things cancel each other out. So you're just going to be left with that function again. But in the process, because of the fundamental theorem of calculus, you are putting these numbers in, and that's why we now have x cubed and 2x inside those symbols. And in the process, we're also taking the derivative of a composite function, so you do also have to multiply by the derivatives of the insides. So make it make sense to you. It'll help you remember the formula better, but there you have it. So the rest of our day is just kind of going to be building on that basic idea, but that's it for the day pretty much. Okay, so let's do this one here. Now, the only reason why this one's a little bit different is just because it's got 2 x's in it, but that's really not that big of a deal. So I want to find the derivative of h. And since h is a composite integral function, I know I'm going to be integrating this, but then right afterwards taking the derivative. So it's just going to go right back to being x squared plus 2x. But instead of x's, I'm going to put parentheses. And because of the fundamental theorem of calculus, you're actually going to write it twice and subtract it. Because in the first set, we're going to plug in sine x. And in the second set, we're going to plug in 7. All right. Now, we also need to multiply by the derivatives of the insides. Okay, so here we go. For this one, the derivative of the inside, well, we have to take the derivative of the inside there, so that's going to be cosine x, right? Derivative of sine is cosine x. And in this case, what's the derivative of 7? Well, that's 0. And since you're multiplying the whole thing by 0, then this whole piece here is just going to go away. And so we're actually left with cosine of x times sine squared x plus 2 sine x. And if you wanted to go the extra step and distribute the cosine in, you could, but it's just not necessary. So I'm going to leave it like that myself. But there you have it. So two things on this one, okay? Whenever you have two x's, you have to plug that number into two spots, right? And then second of all, if you ever have a number in part of your composite function, you're going to be multiplying that by the derivative of that number, which is 0. So that part's actually just going to disappear. So those are the two interesting things. Two x's and numbers become zeros when you do derivatives. All right, so let's go ahead and throw one like that at you guys and see how you do. Go to find homework problem number 3 and do as much of this problem as you can. And when you unpause the video, I will show to you my solution. Okay, so here's the answer to homework problem number 3. So I started by rewriting the function twice, once here and once here. For the left, I plugged in 6 where the t was, and for the right, I plugged in 3x squared where the t was. And then I multiplied by the derivatives of those things. So the derivative of 6 is 0, and the derivative of 3x squared is 6x. Now this whole piece here goes away because you're multiplying it by 0, so it leaves you with a negative 6x being multiplied by everything you see in the brackets there. And notice I'm not simplifying it. You could simplify it if you wanted to. Like you could do 3x squared to the 4th power, and then you could distribute this in. And even after you distribute it, you'd be able to reduce that first fraction a little bit. I'm not going to bother with that, though. I'm just going to leave my answer like that, and I think that's fine for you to do the same. Okay. All right. And we'll go ahead and take a look at one more problem before we call it quits for the day. Example problem number 4. And the only difference about number 4 is that afterwards we're going to plug a number in. So I want to show you guys how to do that. Okay. So part A is asking me to do what we've been doing, which is to find the derivative. So I'm going to write this function twice. With a subtraction sign in between. And you're going to plug in the top number first and the bottom number second. And you're going to multiply by the derivatives of those things on each one. So that's A. All right, let's go ahead and do part B. For part B, we're being asked to find m prime of 1. And so what that means is they actually want me to plug 1 in. Okay, so now technically if it were a free response question you could leave it like this, but you know, in the event of having a multiple choice question you're going to want to be able to work it all the way down to the final answer. So I'm going to go ahead and do that right now. So this is 1. ln of 1 is 0. This is 4. 0 squared is 0 times 1 is 0. This is 16 times 4, which is 64. So the final answer here would be negative 64. Okay, so there it is. So basically, if you want to plug a number in, you have to apply the little rule first to find the derivative, and then you plug the number in. But honestly, none of that's new. That's stuff we've always done before. So let's go ahead and have you guys do one like that. Go ahead and do homework problem number 4. Pause the video here, and when you unpause it, you will see the solution. All right, and here it is. So here's your derivative formula. Let you guys check that. I would imagine some of you guys are still struggling with the square roots, how to find the derivative of square root. But the way you find a derivative of square root is you always do 1 over 2 and then just put that square root on the bottom. And if there's something on the inside, you would also multiply by the derivative of the inside. But in this case, there isn't, so we just leave it. But the derivative of the square root of x is 1 over 2 square root of x. All right. Then after that, we plug in 0. And we were almost fine until we got to here. You can't plug 0 into the bottom of a fraction if it's going to make the bottom equal 0, which it does. And so that's undefined, and therefore the derivative does not exist at that point. This function is not differentiable at 0. And that's that. So I'll release you guys to do the rest of your homework problems on your own, and we'll see you guys in class. Have a good one.